Hello there. So this video tutorial is going to be on how we sketch polynomials. Again, keyword here, sketching. Okay, we're not after a masterpiece in art here, and in accuracy, we expect to find the key points on the curve. We looked at quadratics, and when we had quadratics, we knew that there were 4 key points in general. So the 2 X-intercepts, the Y-intercept, and the vertex. Those 4 points we could find. The Y-intercept was the constant at the end. Constant at the end of the equation. And these 2 points were the roots, the X-intercept. We found the vertex by completing the square. Okay? Now for a general cubic equation, it's a little bit fiddlier, and actually to find equations of minimum points and maximum points, and find the coordinates of the minimum points and maximum points, in the general we need to use a process called calculus, which we don't come across until core 2. So in general we can't find these standard points here using algebraic means. All we're going to be worrying about is, given a polynomial, can we sketch it and find the X-intercepts and the Y-intercepts? It's actually easier than you think. Okay. So let's imagine we've got a function, the graph y is equal to x plus 2 multiplied by x minus 3 all squared. Okay. So just to be clear, that we're only squaring the x minus 3. So really this is x plus 2 multiplied by x minus 3 multiplied by x minus 3. Now, to find the y-intercept, we need to find out where the constant term is. Okay, to find the y-intercept, we know that the y-intercept there is when x is 0. Okay, so we could sub x is 0 into this equation, and we get y is equal to, well, it would be 0 plus 2, so that's 2, multiplied by 0 minus 3, minus 3, 0 minus 3, minus 3. So it's 2 multiplied by minus 3 times minus 3. So that means that y is 18. 2 times 9 is 18. So the intercept is at y-intercept 0, 18. Now, we also need the x-intercepts. And these are where y is equal to 0. Okay? So if we sub in y is equal to 0, we get 0 is equal to x plus 2, x minus 3, x minus 3. Now just like a quadratic, when this isn't a quadratic, this is a cubic. We've got 3 brackets. But to solve this equation, if we've got it in factorised form, it's exactly the same as it would be for quadratics. Except quadratics we only have 2 brackets. Here we've got 3. Here we have that x is equal to minus 2, because one of these brackets has to be 0 if they multiply to 0. In here we have x is 3. We also have x is 3 from here, so this is a repeated solution. It's what we call a repeated root. Okay, because we're going to start using the word root instead of solution. Okay, so we've got a repeated root of 3 and x is 2. Now what does that mean the graph is going to look like? Now, we've got 0, 18, now it goes through there. We know it crosses at minus 2, the x-intercept, that's minus 2, 0. We also have one that's 3, 0 there, a repeated root. Okay? Now, this is the highest power, this polynomial is a cubic polynomial because we've got x times x times x. This is a cubic polynomial. And furthermore, it's a positive cubic polynomial. Okay? So just as that's the general shape for a positive x squared, that's the shape for a negative x squared. The shape for a positive cubic is generally like that. The shape for a negative cubic is going down the other way. For a quartic, we just have, that's a plus x to the 4. We have an extra turning point there. And for a negative, it's going to be negative x to the 4. Okay, they're the general shapes. So here, knowing that we have to start here because it's positive cubic and end up there, that means that we're going to have to go through there. We don't know where the turning points are. We can't calculate them yet. Now this is a problem. We're going to end up going really big here. So the only option really is that it doesn't quite cross it. It just touches it. Okay? And this is an example of why it's repeated groups. The graph touches but doesn't cross. Okay, this is the geometrical significance, the written significance of having a repeated root, because it just touches, it doesn't cross. And so there's our graph of y is equal to x plus 2 multiplied by x minus 3 all squared. We're done. Very simple. Because we can't find these repeated roots, and because we can't find, the vertexes using the methods we've got available to us, we only have to find the y-intercept and the two x-intercepts. And then it becomes very easy. So let's do another example. X plus 1, x minus 2, 4 minus x, and x plus 2. Okay. Y-intercepts, we're going to sub x as 0 in. So we get y is equal to 1 multiplied by minus 2 multiplied by 4 multiplied by minus 2, which is plus 16. So y is 16. So 0, 16 is the y-intercept. To get the x-intercepts, we're going to sub y is equal to 0 and solve the equation. So we get 0 is equal to x plus 1 multiplied by x minus 2 multiplied by 4 minus x multiplied by x plus 2. This bracket here means we get x is minus 1, that's one root. Another one, x is 2, that's another root. This one here, 4 minus x is 0, it means that x is 4. And this one here, we get x is minus 2. So, mark these points all on. We have the y-intercept of 0, 16. And we have x-intercepts. Now, none of these are repeated, so we know that they're going to purely cross. It'll be minus 1, minus 2, plus 2, and plus 4. And what's that going to look like? Now, we've got to be careful. This is basically, this is there's 4 brackets here involving nexus, so it's going to be a quartic, which means it's either going to be look like that if it's plus x to the 4, or like that for minus x to the 4. Now let's see, we've got x times x times minus x, which is minus x cubed, times by another x, means it's minus x to the 4. So it's a negative cubic, and it means we're going to have to somehow make the graph look like this. Let's have a look here. How is this going to go? This is a bit fiddly. Right. I've just realised I've made a mistake. The mistake was here. No, it was here. This shouldn't be a minus. When x is 0, this bracket goes to 2. So that means that this is minus 16, and that makes sense because there was no way of me being able to do that with the graph how it was. So let's do 0 minus 16 there. So that, yeah, that's bad. Now we can go like that. There's our graph of y is equal to x plus 1